This is the second video for chapter 21. We're going to talk about double and triple bonds today. So last time we talked about alkanes, and of course alkanes are hydrocarbons and branched hydrocarbons that all have single bonds. They have carbon and hydrogen and sometimes some other things added as groups or accessories. Alkenes with the E and E ending are the double bonded compounds, and alkynes with a Y and E, those are the triple bonded. So few differences. One is that the ending is going to be E and E. Now that tells us there's double bonds. It doesn't really tell us how many or where, but we put a number in front of the parent that tells where the double bonds are. So like for butene, you could say 1 butene, and you'd know that the first carbon is touching the double bond. We always use the lowest number because obviously it's going to touch two carbons, 1 and 2. So 2 butene would be the second carbon, or the second and third. Same thing with the Y and E, that when you see a Y and E ending, that's the parent ending, and the number of carbons, prefix, same prefix as we used before with the Y and E ending, and then you put a number, sometimes more than one number. If you have more than one number, there's more than one double or triple bond, and there's a comma between numbers, remember. So we'll move on and hopefully see if our computer's locked up. Looks like it's locked up a little bit. So naming double and triple bonds, one other difference. Remember how we picked the end that was closest to a group? Well, now the first thing you look for is the end closest to the double or triple bond, because that takes precedence. So if there's no double or triple bond, find the end closest to a group. Or the way it's stated is that pick the end that gives the lowest group numbers. So we're going to move on and talk a little bit about isomers. In the lab, you had a chance to put together some isomers. You started with butane, and you did one for butene. An isomer is isosceles triangle, 2 equal. So the iso means 2 equal. And what that means is that we're finding some other structures that have the same chemical formula. So the same numbers of C's and H's and parts, but it is a different structure. So, and it doesn't have to be the same name. It's going to be a different name, and it's going to have a different parent chain. Sometimes people say, well, wait a minute, that was pentene, but this one's only got 4, so it can't be an isomer. Well, sure it can. It just has to have the same formula. So add up the C's and H's. If it's got the same formula and it's a different structure, that's an isomer. That's structural isomer. So there are several other types of isomers we're going to look at. One of them being a stereoisomer. And stereoisomer, like this can have a stereoisomer, has asymmetric carbon in the middle. Asymmetric means that it's not the same. So this one's not. Each leg is different. And if you think of a matching, so like if I push this into the view here, think of that as though we're in a mirror, and the asymmetric carbon, or the stereoisomer for that, would be exactly the mirror image. So remember, stereoisomers are a very specific type of structural isomer that are mirror images. The chirality, this just tells you that molecules exist as left and right-handed. L or levo is the left, and D or dextro is the right-handed molecule. And you can see how we have this setup here where most of the groups are on the right-hand side, and then most of the groups on the other one are on the left-hand side. Again, a mirror image. This one doesn't have the simple structure and the simple asymmetric carbon that this first group did. So we're going to talk about geometric isomers, another specific type of structural isomer. You have to have a double or triple bond to have a geometric isomer, and it can't be on the first carbon. So this is what you look for when you see, is there a geometric isomer? If it has a double bond that's not on the first carbon and not on the end, on either end, then it probably could have a geometric isomer. The other qualifier, if it were all hydrogens, it's not going to have a geometric isomer, because when you switch it, there's no real change, because there's a hydrogen up and down, and when you switch it, there's a hydrogen up and down. So it has to have some asymmetrical nature to it, and you can see here, this one in particular, if we call that the green parts, if we call those chlorine, then you can see that when we have the left model, the double bonds are not able to rotate, kind of like having two sticks stuck in. Axle can't rotate because there's two sticks that hold it steady. Then this can't switch, and it's different than this model where we have the two different ends up. Here we have the two different ends down. That would be the cis model, and this would be the trans. So depending on what we have, let's call those carbons now. They're colored different just so we could identify them. That would be 4 carbons. Then you know that's butene. Well, the double bonds on the second carbon, so it's 2-butene. This would be cis-2-butene, and that would be trans-2-butene. So that's somewhat the parent name. You could add groups on to that, and just like you do any other parent name. Those are geometric isomers. What to look for? Double bond or triple bond? Generally, it's going to be a double bond in this case with carbon, and you'll have a double bond or triple bond not on the first carbon. Then if you have that, look to see if you've got some asymmetry about it that can cause a cis and a trans model. So we already talked about stereoisomers. Again, as a group, these are called optical isomers, the left-handed, right-handed, and stereoisomers. Remember, it has to have the asymmetric carbon to be the stereoisomer. And you can see there, they've got one in the mirror, and you can see that the two models, they are mirror images. And when you try to overlay those, they don't overlay the same. There's always 2 of those spheres different, so they aren't actually the same molecule. All right, that finishes up the second day. And short notes this time, work on your review. You do have some practice pages. It's really important to go through and do those practice pages. We will see you on the third set of notes for Chapter 21. Good luck.